Welcome to 2019 higher level. It's question B3, it's an intersecting planes question. So the image on the right shows the entrance structure to Pilo Hotel in County Meath. It comprises of a series of planar glass surfaces. Okay, we can see that image there. Figure B3 shows the plan and elevation of two of the surfaces A and B. So we've got surface A and surface B. So A here, B here. The surfaces are identical and the plan is constructed on a square grid as shown. So here we have our square grid. And they've given us their heights and scale 1:1. Draw the plan and elevation of the intersecting planes A and B. Okay, so we'll start off by drawing our XY line and our elevation and plan view of this. We'll probably have to draw the plan view first. Yeah, and they're actually indicating it. Draw the plan and then the elevation. Alright. So it's 70 by 70. By 70 grid. Okay, and that grid then is divided up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So each one of those is 5 mil. So there, I've completed the grid. Okay, and next I want to add in those planes. So count it out 1, 2, 3, and that's going on for 2. So I'm going from there to there. Here's going to be another point. 1, 2, 3, 1, 2. So put in those planes in heavy here. Okay. And looking at that on my question, to find that point, I need to draw the diagonals. So draw the diagonals there. That's in 1, 2, 3, 4, 4. Okay, so that's the plan of our planes. So next up, we're going to draw our x1, y1, and project up those points in the plane. Okay, we've got heights of 40 and 20 for some of these, and we've other points that are going to be on the ground. So let's measure up at 40 and 20. Okay. Points. Plane A, plane B. Okay, so we've got the plan elevation complete. Determine the dihedral angle between planes A and B. So plane A and B, their line of intersection is here or here. So we want to see that as a true length, and once we have it as a true length, we can project that as a point view, and that will show us the angle or dihedral angle between them. So we want an x1, y1 out here. There's my x and y1. Checked out. My line intersection. I'll also project out the rest of the plane. Okay, heights taken from the elevation. So we've got two heights here. So that height corresponds to here. Let's step it off. I've got a height of 40 then, which corresponds to here. And the point is on the corresponding. Okay, so this is my true, this point here is on the ground, so that's going to be on the xy line, or on the x and y line. Here, same thing, on the x and y line, and there, same thing. So here is my true length. The line of intersection, and that's the projections of the plane. Okay, next we want to look along that true length so that we see it as a point view. So slide and set square, line up with my line of intersection, and draw my x2, y2. We'll project out these points. Okay. Okay, so that's my x1, y1, x2, so we can layer a little bit more, y2. Alright, so going back along, I probably should have said this is an auxiliary elevation because we're projecting from a plan, so my heights come from my elevation. Now I'm projecting from an elevation, creating an auxiliary, projecting from an auxiliary elevation, creating an auxiliary plan. So we'll go back here to our plan view from this. So x, y, x1, y1 back to my plan view. Okay? And if you're ever in doubt, just think we want to find this line as a point. So the distance from my x1, y1 back should be the same for both of those. So that distance there is the same for both of those, so that when we step them off here, it'll create a point. So I'll start with that. Now if you want to index all these points to make life a little bit easier for yourself, absolutely do. Next up, point. I haven't projected it out, I think I don't need to. show it here anyway. That's right. Just rub that out. Okay, I'll just go back and project out this point that I should have projected out. Okay. There. Take that off. What point I just projected up there wasn't thinking at all. That should have come from here, sorry. Ignore that line. Just a bit of a moment. And find it here. Taking all these off your X2, Y2. And those should be in line with one another. Okay, so here, that's a point view. Okay, and if we want to determine the angle, okay, you can measure that angle there. I'm measuring it, I'm getting 79. Yeah, 79. Okay, so that's my dihedral angle. Okay, 79 degrees. Okay, so that is the dihedral angle completed. Right, project, now like I said, just going back to that, if you index these points, it might make life a little bit easier for you, or add colours, okay, it always makes life a little bit easier adding shade or indexing points, okay, but if you want to follow them back along, my distances here have been taken from elevation, my distances here have been taken from my x1, y1 down to my plane. Okay, so project an auxiliary elevation at plane A on the x1, y1, sorry, project an auxiliary elevation of plane A on the line x1, y1. So we've got an auxiliary here, so we just need to extend out from there at 90 degrees to give us our x1, y1. Hence, determine and indicate in degrees the inclination of the plane A to the horizontal plane. Alright, so this line that we're projecting through is resting on the horizontal plane. So that is a horizontal line in reality. So because it's a horizontal line in reality, this is a true length line. Same way that if I throw my pen down on the desk there, I can measure the true length of it because you're looking perpendicular, looking straight down on top of it. So we can look out along that pen and see it as a point view. We know that any point or any line projected as a point, we see a plane containing that line as a point. It's one of the key principles. So let's set up all of that. Part C. Just project this line out slightly. Anywhere out there, it doesn't give us a distance out to the x1, y1. And I'll draw my x1, y1 just here. so we want to find plane A. So let's project out the points of plane A. Point there, and that's point there. So here's my x1, y1. Okay, projecting from plan, creating an auxiliary elevation, so my heights again are coming from my elevation. So this is plane A. We'll start here. Okay, so that point and that point are both on the x1, y1. Here they are, so they're on the x1, y1 there. Then we'll go up to this point, which is here. Step it out. And finally, my height's 60. So that point, follow it out. There it is. Okay, so that is an edge view of that plane A. They asked us to indicate in degrees what their angle is, so either side there of the x1, y1 on the plane, and that is coming out at 104 degrees, so 104 degrees. Okay, or if we made it on the opposite side, we get 76. Okay, so that's part C done there. Laser lighting is used to enhance the entrance to the hotel at night. The inclined straight line PQ represents the path of a laser beam. Okay, so we've got PQ as a laser beam. Alright, so let's just first of all locate PQ. Determine the points of intersection of the line PQ and points. Okay, so first of all, we'll just locate point PQ. So 1, 2, 3, 4, 5, 6, 7. That's point P. Point Q is there. P is on the ground here. And Q is at that same height. So that's Q. Alright, so I'm just going to use a cutter here to show our laser being shown. That's our laser. Q. Q. Alright, so to determine the points of intersection, points of intersection PQ and the lines A and B. Okay, so I thought it was just plane A. If it was plane A only, what you could do is, because we have an edge of the plane, you can project up here. P is on the ground, Q is at the height, so you could draw your laser, and where it hits the plane, that would give us a representation of it, or a point of intersection of it. Or we could project that down onto our laser pointer and up onto our laser again. Okay, and because we're going to have to find it where it intersects plane B as well, we may as well just use one method so it's kind of consistent and easier for an examiner to follow. So what I'm going to suggest is we use maybe a reference line. So yeah, if I determine this point and this point, project them up, that's on the ground, this is on there. So here's a reference line. Okay, so where that line travels. Okay, it's like almost actually a vertical section, projected up, so that is where that vertical section cuts it, and that's where it intersects it. So that's going to be 1 point, and then we'll do the same thing here. So this is on the ground, this is on that surface. Just heavy this in just so we can see it a little bit better. That is the other projection. Okay, so that is where it intersects there. Just trying to point the intersection of PQ. Yeah, so that's where it intersects there, and then we'll project that back down onto our laser. Project that back down onto our laser. So those are the projections of where it intersects the planes AB. Okay, so that was our 2019 intersecting planes question. Okay, first couple of bits kind of handy and a little bit of thinking involved there, and to work out the projections of a laser.